Good morning, all of you. So, as we know, in last class, I taught energy, but of course, today once again I will discuss it for a few minutes, and later we will go to the types of energies. So, all of you should remember in this chapter, the first part we will study what do you mean by work or work done. So, as it is, a few of you are joined only today, so you can remember work or work done. The formula is work done W is equals to force into displacement. Mr. Johan, at least learn the formula. Later, offline class, I will explain. So, work done is equals to what is the formula? Force into displacement means F into S, which is equals to work done. Is it okay, clear? So, work done is equals to force into displacement. Now, the unit of work done is joules, which will represent with the J, which is equals to unit of force is Newton and unit of displacement is meter. So Newton into meter, which is equals to joules. So this is what we studied in the last week. What is work and what is the unit of work done? So this is what the SI unit. So what is the SI unit of work done, Mr. Johan? SI unit of work done is what? Joules. And joule is equals to Newton into meter. And the formula, work done formula is equals to force into displacement. Now, in yesterday's class, we started energy. What do you mean by energy means? That is what we will say, a capacity to do work. So I'm having more capacity means I'm having more energy to do the work. As we cannot see the energy, but we can experience the work done by the energy. So that is what we will say, capacity to do work or to complete the work done. Work is called, what is to call? All of you. A capacity to do work is only called as what? Mitakshri? We used to call as energy. Understanding? So, the SI unit of energy is also, what is the SI unit of energy? Everybody? Harish? Gokul? Joules only. So, the SI unit of energy is also joules, which will represent with the capital J. Is it okay, guys? Abhirami? Harish? That is what you have to remember. So the SI unit of energy is also joules only. So if I'll say I have done 1 joule of work done, means in the sense of how much energy I have been spent. 1 joule of work done is over, means my body is possessing how much amount of energy. Anybody? 1 joule of energy. Do you understand, all of you? So always you have to remember the conclusion from yesterday's class. The energy possessed by a body is equals to amount of work done. Is it right or wrong? My body will possess 1,000 joules of energy. So that how much amount of work done I can do? Mr. Arizeras? I can do 1,000 joules of work done. That is what you all should remember. If I will get 100 joules of energy, I can do 100 joules of work. If I will get 1,000 joules of energy, 1,000 joules of work done. That is what always remember. Energy possessed by a body, possessed means released, possessed by a body or object which is equals to amount of work done or amount of energy. Amount of energy possessed by a body is equals to amount of work done. Is it okay, everybody? So that is what it is. So energy means we can say it is the capacity or ability to do the work. Ability of a body to do the work is only called as energy. So both work and energy. What is the SI unit of work and energy? Everybody? What is the SI unit of work and energy? Everyone?
Joules.
Joules only. Please kindly remember. So what is the SI unit of work and energy? Everybody? Joules. Okay? But for work, instead of joule, also we can write what? Newton meter. That is you have to remember. Understand, Omar? Nimish? Okay. Now, in our today's class, we are going to
Yes,
discuss
sir.
different types of energies. In that, mainly two energies we need for our class 9. That is what most important energy is. In our today's class, we will study one energy and the derivation also. So, all of you keep adding types of energies. Types of energies are different forms of energies. Your choice. Types of energies. Now, all of you one by one, start opening your mouth and tell me what is the known forms of energies for you? I want to know. Let me see how many of you knows. First one. What is the different forms of energies?
Sir, kinetic energy, geothermal energy,
Okay, kinetic energy, very good. At least you knows what is kinetic energy. I'm happy. Heard at least word. Next,
geothermal energy,
first one, potential energy. Next one, potential energy. Now somebody used a word called as mechanical. Who is that? Ms. Hariseras? Yes, this both together we used to call. What we used to call? Yatakshri?
Mechanical energy.
Mechanical energy. Understand, Mr. Hariseras?
Yes, sir.
Next, tell me, heat energy. All of you? Omar is saying geothermal energy. Very good. Geothermal energy. Or we can say thermal energy. Heat energy means that only. Next, all of you. Light energy. Tell me what is the forms of energy you know. You don't know chemical energy? Do you people don't know chemical energy? Please respond. Chemical energy. Others forms. No other form you people knows. Electrical energy, sound energy. Don't know? Sound energy. Respond other forms of energy. Electrical energy.
Mechanical energies.
Yeah, electrical energy. Next one. Others. Nuclear energy. You don't know nuclear bombs. Yes or no? Nuclear energy. Next one. Any other forms? Tidal energy. Have you heard tidal energy? Next
Sir,
one.
hydro energies.
Yes. Wind energy. Hydro energy, of course, tidal energy, tides and hydro energy, with the water. Hydro energy, that is what hydroelectricity will say. So, like this, we're having different forms of energies. This all we are saying that variable types of energies are energy in different forms. Okay, but for class 9th, we will only discuss two forms of energies. That is what the first two forms of energies, which we used to say. What is the first two forms of energies for class 9? One is kinetic energy, and another one is potential energy. And this together, what we used to call everybody? Kinetic energy plus potential energy together, what we used to call all of you?
Mechanical energy.
Mechanical energy. That is what you have to remember. Please mark it, everybody. So this is what. So these two only we'll discuss in entire class 9. And remember, throughout your life, the most important energy is what energy? Kinetic energy and as well as the potential energy. And the derivation is also very important. Potential energy derivation is very, very simple, which we already studied. Work done against to gravity. That is only is equals to potential energy. So that we will study in the later class again. Now today we will focus on kinetic energy. So we study kinetic energy, everybody? All of you? That is. So please all of you keep adding, write this all the types of energies. Now what is the energy we are going to study, guys? Everyone, Mr. Nimish, we are going to study KE, kinetic energy. KE, which is known as kinetic energy. Please, all of you keep adding. Okay, that is. Now, let us observe what do you mean by this kinetic energy and how it will be. We will discuss now. You all knows that in yesterday's class, as we are hammering the nail into the wooden block. Do you remember that, Mitakshri? as we are hammering the nail into the wooden block. Now, are you people are hitting the hammer just by placing it above the nail, or you people are lifting back and you are going forward and hitting? I want response from you people. Are you people are hitting, taking the hammer back position, and you are going and hitting the nail, or just from above the hammer you are putting and hitting? Anybody?
So lifting back and hitting.
Lifting back and hitting continuously. Yes or no, guys? Please respond, all of you.
Yes, sir.
Yes, sir.
Why we are doing this motion? Because whenever we have taken this hammer back, it will be stored with some energy. Is it yes or no, guys? All of you? So now that stored energy only, if you have taken more back, more energy will store. Understanding? Less height, less energy. So if I am taking the hammer back, so I am storing some kind of energy in it, and with that energy, if I hit the nail fastly, so that the nail will penetrate or drilled into the where wooden block. That is what will happen. Yes or no? Abhirami, Mitakshri. So now, here if you notice it, as I am moving the hammer, if I am moving the hammer, if you all notice it, then only it can drive the nail into the wood. Is it true or not? Without moving the hammer, is it possible to drive the nail into the hammer? Into the wood, Mr. Omar, Akilan? Is it possible? Without motion, without moving the hammer, is it possible to drive the nail into the wood? I'm asking the question. Anybody? Is it possible?
No, sir.
No. Understanding? So if you want to drive the nail into the wood, you must need to move the hammer. Same way. Now, let me imagine Mr. Omar is a football player now, and here he is having a football. Now, is it possible to keep the goal or seeing the motion in the football without kicking his leg? Is it possible? Yes, Mr. Hariseras, Akilan? No. Is it yes or no? So without motion of this ball, understand, without moving, is it possible to put the ball? All of you. Yes, please. Nobody? So now, when he want to create a motion in this football, he has to hit with his leg. Is it yes, Metakshri? So when he is hitting with the leg, is it he need to move the leg or not? Simply he will kick means it will go, or he need to move the leg. You have to respond. You are all recently only football matches over. Football World Cup. Nimesh, he has to lift the leg, understanding back, and he will hit forcefully. So that then only the ball will travel faster. So you can notice here, every case, even if I'm moving the hammer to drive the nail into the wood, same way to create a motion. If I kicks the ball only, the stationary ball will start moving. Do you understanding? Stationary ball will start moving when I kicks. A football player will kicks it. Same way, whatever I am doing, you can see, suppose if I am running, without running, is it possible to reach the target? All of you, suppose I am an athlete. Without running, is it possible to reach there? Everybody, open your mouth. Yes, please. No. Yes or no? Same way. Now, a ball is going to hit the stumps. Now the stumps will fall down. So now a moving cricket ball without moving, without throwing cricket ball, is it possible to break the stumps? Anybody? What happened? No. So if you all notice it in all these cases, you can see I am driving a motorcycle, then only my bike will move forward. I am running, then only I can go forward. I am hitting the stumps with the moving cricket ball, then only stumps will fall down. I am hitting the nail by moving the hammer, then only the nail will go into the wood. So if you all observe here, every case I am speaking about a motion. Have you all noticed it? Moving or motion. Yes or no? Everybody? Yes, please respond. All of you.
Yes, sir.
Yes. So whatever body, if you have taken cricket ball or football or hammer, or I am myself, I am running, or I am riding my bike, whatever it is. So the energy possessed by the body, understanding, when the body is in motion, due to the motion, if your body is exerting or possessing the energy, that energy only what we used to call, Harizeras? We
Kinetic
call
energy.
that kinetic energy. All of you should remember, kinetic energy means, Mr. Arun Kailas, understand? So, nothing, it will be very simple. The capacity to do the work as it is possess the energy only when it is in motion or moving object. So that is what we used to call as kinetic energy. So all of you should remember that a moving object having a, this is the point you have to remember. Definition everybody, but this you need to know. Mr. Kaushik, understanding? Moving object has the capacity to do work. Now, moving hammer doing some work. Anybody, what is the work doing by the hammer? Moving hammer. Anybody? Moving hammer doing some work. What is doing? Open your mouth and say. It is driving the nail into the where? Nail into the wood. Understanding? Same way, a moving football, sorry, player kicking the football with his leg, so that a moving leg only making the football to getting into motion, create a motion in the football. Same way, a moving motorcycle only will make us to travel. A moving ball only will break the stumps. These all the cases. A moving object has a capacity to do the work as it possesses energy. Why it is having capacity? During the motion, it will release some energy. It will possesses energy. So the energy possessed by a body during motion is only called as what energy we used to call? Everybody? Yes, please. What energy we used to call? Nobody will answer. The energy possessed by a body by its motion, what we used to call? By the moving object is only called as which energy, guys?
Kinetic energy, sir.
Moving object is called kinetic energy. Please learn it. Kinetic energy. Okay. Now, if you want, you can write the definition. The energy possessed by a body, definition number. Energy possessed by a body by virtue of its position, motion. Virtue of its motion is only called as kinetic energy. Understand, Omar, Akilan? So due to the motion, whatever the energy is releasing by the body, that what energy we
Yes,
used to
sir.
call, guys? Whatever the energy due to the motion, movement is called as what? We used to call as kinetic energy. Okay. So what is the examples of kinetic energy? Anyone can tell me examples of kinetic energy? Flowing water is the example of kinetic energy. I want the response from you all. Flowing energy, flowing water is the example of kinetic energy. Yes.
Yes,
Flowing
sir.
water. Understanding? Next. Firing a bullet. Is it a kinetic energy or mechanical? Kinetic energy, some other form of energy. Mithakshri. Next. Moving ball breaks stumps. Moving ball breaks stumps. Is it a kinetic energy or not?
Yes, sir.
Yes. Breaks stumps. Next. Arun. Can you tell me windmill? Have you watched the windmill anywhere on the above hill stations and all? They'll put the windmills. Yes or no? Windmills is the kinetic energy or not? Yes, Mithakshri, Abhirami?
Yes, sir.
Yes. So how you are saying windmills is a kinetic energy? Can you tell me? Anyone? Harizeras? Akilan? How windmill is a kinetic energy? Anyone? Because it is having a
Because
what?
it is moving.
Yes, it is having a three rotating wheels. You can see it looks like a wheel. Do you understanding? Three arms will be there. They'll be keep on rotating, and they will generate which energy? Anybody? Which energy they will generate?
Electricity, sir.
Electrical energy. Understanding? By wind energy. Wind energy will be converting into electrical energy. That is what. So these all are the examples of kinetic energy. All of you should remember that. Anything doubt? Anybody can ask. Clear, guys? All of you should respond. Write it till here. I'm giving 1 minute time. Anyone having anything doubt, you can ask me, or else you can write it. Do it fast.
Sir,
Yes, Umar.
can you explain kinetic energy again?
Okay, Omar. Nothing, Omar. Suppose you want to go to from here to here. You are at a position A. Now you are reaching. You want to reach the position B. So what is the ways you can go, Omar? Suppose you are standing here. Now is it automatically will you go reach to the point B? Is it possible?
No, sir.
Now what you will do? You will start by walking.
Walk, sir.
Go by walking. Now during the walking, your body will produce energy or not?
Yes, sir.
Same way, if you want to go by running, you are running also your body will produce or not?
Yes, sir.
You can go by driving the bike. Understanding? Now, if you are driving, your bike will produce the energy or not?
Yes, sir.
So that energy, due to your motion, or your body is releasing the energy when you are moving. The energy releasing during the motion is only called as kinetic energy. That is what it is. So you see that water is in motion, flowing water. Water are moving, water is moving, so that kinetic energy. Moving ball breaks the stumps. So if I throw the ball, that ball will come and will hurt you. If it will hit, it will hurt you or not.
Yes, sir. It will hurt, sir.
When it is traveling, it is possessing some energy. That energy only kinetic energy will say. So whatever the object, when it is in motion, it will possess or it will release some energy. That energy only called as kinetic energy. Is it okay?
Okay. Yes, sir.
Understand?
Yes, sir.
That is. Anybody having doubt? Johan, Harini, understand Harini?
Yes, sir.
Okay, very good. At least New Year Harini is responding. I'm happy. Happy New Year. Write it. So that is what it is. So whatever the example, when the body is in motion, you can say what energy is possessing. Everybody. It is possessing what energy, Mr. Johan? It is possessing kinetic energy. That is you have to remember. When the body is in motion, the energy possessed by the body is kinetic energy. That is what you have to remember. Mr. Kaushik, clear?
Yes, sir.
So today's class, we will derive the formula for kinetic energy. This is the most important one for entire class 9 and as well as in our higher classes. So please all of you keep reading. Formula for kinetic energy. Now, if you want to derive the kinetic energy formula, again you need to know equations of motion. Now, Mr. Arun will say equations of motion, 3 equations, formulas. Fastly, Arun. V equals to
U
U
plus
T. Second one,
S is
S
equal
is
to
equal
UT
to
plus
UT plus half
half
AT.
AT square.
Third one, V square
2A
minus U square is
minus
equal
U
to.
square is equal to 2A.
Yes.
Okay, so all of you remember these 3 formulas. Now, so formula for kinetic energy. Shall we start now? Everybody, Abhirami?
Yes, sir.
Okay, now first point. Let us consider, write it. Let us consider, neatly write. Let us consider a body of mass M initially at rest. INI. Initially at rest. Initially at rest means somebody is zero. Mr. Omar, what is that? Can you say? Initially at rest, somebody is zero. Body is at rest. Who is zero initially? Check it, everybody. You have to tell me.
Initial velocity is 0, sir.
Initial velocity is zero. Very good, Mitakshri. That is what. Okay. Now, a force F, write the point. A force F is applied. A force F is applied. How we need to apply, guys? Exactly perpendicular or less than perpendicular? 0 to. What is the angle we have to apply the force? In between 0 to
90 degrees.
90 degrees. If it is 90 degrees, what is the force? If it is perpendicularly, what is the force, Amma? Force is equals to, if you are applying the force, work done is equals to what?
0, sir.
0, sir.
0. That is you have to remember that. So, a force is applied on the body. Understand, Omar? Force
Yes,
is
sir.
applied on the body. So, now the body will show the displacement or not. You should respond. So that the body gains the velocity. The body gains the velocity. So what is the velocity? Can you tell me? What is the velocity representing? Already initial velocity equals to 0. Over. Now what is the velocity gained by the body? Mitakshri? V.
Final velocity, sir.
Understanding? V after traveling certain distance. After traveling a distance. What is the symbol of distance? Nimish? Symbol of distance. Yes. Okay. That is what you have to remember. Now, let A be the, what do you mean by A? Anyone can tell? You all know terminology. A means what? Change in velocity, 0 to final velocity V. So what is the change in velocity called as? All of you.
Acceleration.
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 Okay. Let A be the acceleration produced in the body. Is it okay, Gokul? All of you?
Yes, sir.
That is what. So till here, according to this, draw the diagram. Now you can see how I will draw the diagram. You all should neatly say that first. A body is in what position? Everybody, check it. A body is in what position now? First beginning. Initially is at what position, Omar? Initially is at rest. Understanding?
Yes, sir.
So initially is at rest. Let me take this point is A. Okay. Now initial velocity is at rest. So initial velocity is how much, Amma? 0 meter per second. Okay. Now I am applying the force. I am applying the force. Now after certain distance, after traveling certain distance, the body come to the position B and it's gained some velocity. What is that velocity we represented? Final velocity. What is that velocity? We represented with what? V. And it is traveled a distance is S. This is what the distance traveled by the body due to the applied force. Anything doubt? Anyone can ask me. Clear, guys? Yes or no? Please respond. All of you?
Yes, sir.
Yes, that is what it is. Now, so you see that due to the applied force, the change in velocity is V and the distance traveled is S. So this is what the force direction also. Now, we observing the body is moving from A to B. A to B means using the Newton's second law of motion. Can you tell me what is the applied force? F is equals to what? From the Newton's second law. Yes, Harish? Omar? Newton's second law. What is the applied
Yes,
force?
sir.
50 plus of 80 squares.
Yes. No, Newton's second law I'm asking. Newton's second law.
F is equal to NA, sir.
Yes. According to the Newton's second law of motion, the force applied on this body is equals to mass of the body and as well as acceleration produced by the body. Is it right or wrong? Mitakshri, Abhirami, everybody? Yes, please. All of you.
Yes, sir.
Why? Why I am taking this one? Because I observed that body is moving from where to where? Yes, please.
Initial to final positions.
Yes, it is observing that it is moving from A to B. Understanding? So that change in acceleration So observing the body moving from A to B. A to B. So that is what. Due to that, using Newton's second law of motion. So F is equals to what is the formula? Everybody, you must answer. F is equals to mass into acceleration. Okay. Now, what is the given data? Check it, everybody. Initial velocity is 0. Some final velocity is attained, and we don't want that. And acceleration is equals to also we know, and distance traveled is yes. So now tell me, based upon this, which equation we can apply? We know the initial velocity, we know the final velocity, we know the acceleration and distance. No time is mentioned. So which equation of motion we will use? Anybody?
E squared minus U squared equal to 2AS.
We know this all the things. Understanding? So which equation we will use? Everybody? From
Third equations.
Third equation, sir.
third equation of motion. Equation of motion. What is the third equation of motion? Fastly, everybody. Yes,
E
please.
squared minus U squared
V
equal to
square
2AS.
is V square minus U square is equals to 2AS, or we all know you can write your choice. 2AS is equals to V square minus U square. Now from that, somebody is 0. We all know that body is starting from rest. From rest. So that who is 0? Initial velocity is 0. So if I substitute this, then what is the equation will come? Initial velocity 0, v square minus 0 square is equals to 2as. So from that, I will say v square is equals to 2as and v is equals to, observe very carefully, or you can take distance. Okay, as we need a distance. From that you can take. So now tell me, what is the distance formula from this? V square by, everybody, V square by, now 2a is in multiplication. Will come this side, what will become? Everybody,
Equations, 2AS.
is equals to distance. So please write it, all of you. Okay, so I will say S is equals to V square by 2a. So that is what. Is there anything doubt in this? Ask me. Distance traveled by the body is equals to V square by 2a. Yes or no, Mitakshri? Yes? All of you?
Yes, sir.
Clear any doubt? Anybody? Please ask me. Now, you all knows that, guys. In our today's class, at the beginning we studied. Once again, I'm going and showing you. You all notice it. If I am having 1 joule of, if I have done 1 joule of work done, means my body is possessing how much energy? Everybody?
1 joule of energy.
1 joule of energy. Now, if my body is possessing 1000 joules of energy, means how much work done I can do? Everybody?
1000 joules of
1000 joules of
1000 joules of energy. Means in the sense of, can I say, Mitakshri, Abhiram, everybody, work done is equals to energy possessed. Is it right or wrong?
Yes,
Yes.
sir.
Yes, sir.
Can I say it or not? Everybody, everyone should say. Yes, please.
Yes, sir.
What? So observe very carefully. According to the Newton's second law, we all knows that the force applied on the body is equals to m into a, and distance traveled by the body. What is the equation we got? Distance traveled by the body. V square by
E squared divided by 2A.
V square by 2a. Now observe, a force F is applied. A force F is applied and on the body, and the body is traveling a distance, and it has moved a displacement, yes, a displacement, yes. Now we know work done by the body is equals to what, guys? Work done by the body is equals to what? Energy possessed by the body. So now, is it moving body or stationary body? Is it moving body or stationary body? Everybody,
Moving body, sir.
moving body. Moving body means which energy it is? All of you.
Kinetic energy, sir.
Kinetic energy. That is what you have to remember. So, what is the work done formula? All of you should tell me. Work done is equals to, everybody open your mouth. Work done is equals to, Mr. Nimish, force into displacement. Okay. That is what. So substitute equation 1 and 2 in equation 3. Let me consider this is the equation 3. Now substitute equation 1 and 2 in equation 3. So tell me equation 1. What is the equation 1? Everybody. So I will say work done is equals to energy is equals to kinetic energy. Is it right or wrong? Abhirami, Mitakshri? That is what. So which is equals to force. Force is equals to what? We know that. What is the formula? Mass into acceleration. Same way into displacement. Displacement means what? V square by. Check it all of you. V square by. What we got? V square by 2a. So a will get cancelled. So which is equals to m into v square divided by 2. So this by 2 I will take it as a 1 by 2 separately into mass into velocity square. So this is only formula for kinetic energy. So what is the kinetic energy formula? Everybody can tell me. What is the kinetic
By 2
energy
into
formula?
mass. Velocity. V square.
Sir, half
Kinetic
into
energy.
m into v square.
Kinetic energy is equals to 1 by 2 into mass of the body into velocity of the body. Is it okay, guys? Velocity of the body square. Square is there. Kv square. Half mv square. How to read this one? Half mv square. That is what you have to remember. Okay. So hope you all understand or not. Yes, please. It's very, very simple derivation. Okay. Omar, understand, Omar?
Yes,
Arizera?
sir.
Okay.
Yes, sir.
So please solve it. Now meeting is going to end. Come back and solve it. Anywhere, any doubt, please kindly ask me. This is the most important derivation for you people. So very simple derivation. Any difficulty, Mitakshri?
No, sir.
Okay. So that is what. So please start solving from the beginning. Anybody having any doubt, you can ask. Gokul, understand Gokul?